Hello everybody and welcome back to our video course. Today we are going to create a library of structural profiles, and we will start first with the UPE channel. So what's the plan? If I open the standard U profile in Plant3d, we can look at how it's built, and then we'll recreate it using our own primitives. Basically, we'll take two rectangles, one for the bottom flange and one for the top flange, and the web will simply be a box between them. So top flange, bottom flange, the web, and after that we'll just add fillets at the corners where the flanges connect to the web. These fillets are something we already made in previous short video. I'll leave the link so you can check it out. I've also prepared a table with the dimensions of standard UPE profiles. Those are according to European standards. In the table we have total height, H, flange width, B, web and flange thicknesses, T, W and TF, and the y coordinate of the centroid, ys, and the fillet radius, r. Okay, that's clear, and let's start coding. So, create a new file. I will call it profile_u.py. And first we will import everything from primitives, and also I import it enum from enum. I will show you how we will use it in our profile positions. So this we don't need, so just we'll delete it. So our profile can be placed in different positions like center, top, bottom, left, right, etc. For this reason, we will create a class and call it position u, inherited from enum. So for each enum, we will define a value for center 0, right 1, left 2, centroid 3, top 4, etc. And then we will use it. So I also would prepare docstring here. Inside the docstring, I like to add a small ASCII diagram. This helps to visualize how the profile is oriented. So what I propose, I would fill the top row with top left, top centroid, top and top right. It would look like this. Then we will repeat the same for the middle line, just only insert the values of left, center, centroid and right. And the last row for the bottom, left corner, centroid and center and right corner, and that's it. Then I will show you how we could see how it works. So if I go to our test module, just to see how this position U as ASCII is going to work, so I will just create some variable, call it position, and call this position U class. So first of all, there is drop down menu, from which I could select any position I want, and also here you can see this ASCII, so I can easily understand which position exactly I need. Okay, so this is how we are going to use this. So then we just have to move uh, our object, our U channel, to the position we need using this dimension of B, H, and YS. So we will create a method inside our enum, and I will call this method getTranslation. This method will return how much we need to move our profile in X or Y direction, depending on which position we choose. So we will define 3 arguments. First will be flange length. The second will be web height. And YS, it is centroid offset. Okay, so web height, and let's align it a bit, and the last one is YS, also float type. Good. Okay, then we will build a dictionary. I'll call it position map, where each position has a corresponding X and Y translation. For example, position U dot center, no movement, so blank. Position U dot right, move by X, move by minus half of flange length. The same, so minus flange length divided by 2. So position right, it will be, actually I will copy it but in the plus direction. For position centroid, it will be actually the same but minus YS. And feel the same for top position, so it will have the same values, but also we add here movement by Y direction, so we move it down to catch the top line, and after we have all the top line here, I will copy all of this for the top, and make it for the bottom positions. Just move this U profile, U channel to the up and to catch the bottom line positions. And finally, we return the translation dictionary for the current position using position map.get and argument self and blank. So that means, depending on the selected position, we'll get a ready-to-use arguments for X and Y dictionary for translation. Good. Now let's create our main class. Call it profile UPE, inherited from shape object. Inside it, I'll define an inner enum size class listing all the standard UPE size from UPE 80 up to UPE 400. In Excel file, I prepared an expression which will help me to fulfill all the sizes in this enum class. So I will just copy paste it here. And also I prepared the dimensions dictionary based on the table in Excel file. So let's start with our init method. So we will need here s, also size. It will have type of size or int. Also we will need the height of our channel and position, of course, and I will define the default position to the center. Since our class should accept either an integer or any num value, we'll add a helper function, call it resolve size. This function will check if size is an integer and exists in the dimensions dictionary, and then it converts into the enum, or if it is already an enum value, so we'll just return it. So let's create this function. Okay, so the arguments we need is the size, the class, and the dictionary where we will check the keys. So if is in instance size integer, and if it is in dimensions, we will make it the instance of enum class. Else we will raise the error that it is out of dictionary. Else, if it is instance of enum class, we just return it. Otherwise, else the type error should occur that it is neither of integer class nor of enum class, so we will receive nothing, I think. That will make our constructor more flexible and easier, and we will be able to choose how we will define the size of our U channel. I think that it will help us in the future, for sure. So we resolved the size, and now let's retrieve all the parameters from the dimensions dictionary. At first, let's define a smaller dictionary D, where we will store all the dimensions selected by size. So then let's define all the variables of self.h equals d by key h, self.b, also self.tw, then self.tf, d by key f, and self.ys equals d by key ys, and self.r equals d by r, and also let's keep self.height. Okay, so now we have all the variables, and it's time to start with geometry creation. I will also use for this helper method, let's call it create geometry, and we will create it separately here. So as arguments we will need self and s, and it will return shape object. Okay. So let's build. Let's start from the web. Web, it is a simple box. So box s, then length, width, and height, and we should translate it, we should move it to the left. So we move it first the half of web thickness and also the half of flange length. Okay, then we create the top and bottom flanges. Each is also a box, but we should translate it upward and downward. So top flange we translate upward, and let's just copy this code, and it will be the bottom flange. The difference is also only we just translate it to the bottom, and that's it. Also, we will need fillets. We already knew how to create them, so we use also radius and height and translate it to the corner, to the left bottom corner, first one, and the second one we move to the top left corner, but first we need to rotate it on 90 degrees because it is mirrored. Yes, it is mirrored bottom one. So we rotate it and move to the top. So here we change directions, and that's it. Then we just return web combined with all the bodies. So it will be the list from flange, top, and fillets. Okay, and everything remains just to solve position of our view channel. So if the chosen position is not the center, so then we apply translation. So we need arguments. These arguments we will receive from our getTranslation method. After we have these arguments, we just define translation. We define translation to our body using these translate arguments, and that's it. So let's test what we have done. So O1 equals profile UPE as then the size, so profile UPE.size.UPE160. The height let's have 50, and position U dot centroid. Okay, so don't forget that we need to restart AutoCAD after we register scripts. So after we have restarted the AutoCAD, oh, he has something strange. So let's check our code. Okay, so I think that we messed up with dimensions somewhere here, like web. Okay, yes, here it should be self.tw, like thickness web, and height was the thickness, because you can see here, yes, it is tw and h. So there was a mistake, and so again, let's register the script and restart it. Okay, now it's good. And you know what? I think that we have to check all the sizes in order to be sure that everything is okay. So let's make a loop for size in profile UPE.size, and here let's use size. And also I think that we have to move each instance, each object in order to not to have a mess, in order to see all of them, so I will just have the variable, let's call it instance space, and each time we will increase it on the flange length. And that's it. Then we just move each view profile on this space, and we will have zero of them. Okay, so register and restart AutoCAD and start it again. Okay, and check what we have. Copy this test SCP script. Okay, good. So everything works fine. That's all for today's video. Thank you for watching and see you in the next one.